Hi guys, I hope you're good and I hope you're well. Welcome to TS Tutoring, and today we are doing Boyle's Law. So let's check out what does Boyle's Law say. So this is the definition of Boyle's Law. It says that the pressure and volume of a gas are inversely proportional to each other, as long as the temperature and the quantity of the gas are kept constant, right? So Boyle's law focuses on two things, right? Pressure and volume. What's the relationship? They're inversely proportional. What do we mean by inversely proportional? We mean when the other one increases, the other one decreases. So if the pressure increases, we expect the volume to decrease. If the volume increases, we expect the pressure to decrease, right? But there's a condition. Only if the temperature and the quantity of the gas, they are kept constant. So the temperature must be kept constant. I hope it's clear, right? So the relationship is that the pressure and volume are inversely proportional to each other, as long as we keep the temperature and the quantity or the amount of the gas constant, right? So let's draw a diagram to explain what we mean. Let's say we have a container, right? This container, let's say it's a 5-liter container. It's filled with gas molecules, right? I'm gonna do the black dots, they represent the gas. 1, 2, 3, 4, 5, 6, 7. Now, do you see how free these gas molecules are? Let's say the pressure in this container, let's say it's equals to 1,5 atm, right? Now, according to Boyle's law, what will happen if the same container we compress it? Let's draw let's say you compress the container, right? Okay, I don't want to draw. I want to draw the new container, a compressed container with the same number of molecules. So if we compressed the container, we now have a small container. Obviously, its volume, what's going to happen to the volume? It's now being reduced, isn't it? Let's say now the volume is 2 liters, right? Now, the same gas molecules, look at them. I said that's 7, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, do you see that the gas molecules are now compact, right? They're now closer to each other. They now collide with each other and with the walls of the container. We have reduced the temperature. But what did we do to the pressure? According to Boyle, the pressure and the volume are inversely proportional. If the other one decreases, the other one increases, right? Now, we move from 5 liter to 2 liter. We decrease the volume. What's going to happen to the pressure? Well, you guessed right? The pressure is going to increase. So now, because of more collisions and the closeness of the particles to each other, the pressure increases, right? Let's say it goes to, let's say 3 atm, right? So now, the volume got decreased from 5 liter to 2 liter. The container became small. The molecules became closer to each other. They collided with each other and with the walls of the container. Now that increased the pressure. The pressure went from 1.5 atm to 3 atm. But the condition is that the temperature and the mass, they are what? They are constant. Don't change the temperature, don't change the quantity of the gas. Let them remain constant. So now, the main equation of Boyle's law is that pressure 1 and volume number 1 is equals to pressure 2 and volume number 2. If you look here, we had pressure 1, 1.5 atm, volume 1, 5 liter, pressure 2, 3 atm, and the volume 2, 2 liter. Now, all the questions that are based on Boyle's law, we are either given 1, 2, 3, we're looking for the fourth one, right? Whether the second pressure or the second volume. Or you might be given both second conditions and one of the first, maybe one pressure here. We are looking for V1. So let's check an example and let's see how we can apply Boyle's law. Now, let's look at this example. It says that a 3-liter container has a gas pressure of 4.7 atm. If the volume of the container is decreased to 1.5 liters, what is the new pressure inside the container, right? So let's look at our data. We know the equation we need to use is P1 V1 is equals to P2 V2. What are we given? Let's write our data. Well, we know that P1 is equals to 4.7 atm. What about V1? V1 is 3 liters. Do we have P2? No, we don't. We want that, right? Do we have V2? Of course, 1.5 liter. So already we are decreasing the volume from 3 liter to 1.5, right? Now let's see what's going to be our pressure. Let's plug in our values. P1 is 4.7. V1 is how much? 3. P2, we don't know. How about V2? 1.5, right? Now let's multiply this to get 4.7 times 3. Well, let's take our calculators. We are going to get that this one gives us 14.1, which is equals to P2 multiplied by 1.5. Now we're looking for P2. Let's divide both sides by 1.5. We cancel. And now we get that our pressure number 2 will be equals to 9.4 atm. Now, let's see if the law still holds. We said the pressure and volume are inversely proportional. If the other one increases, the other one decreases. If the other one decreases, the other one increases. Now, the volume moved from 3 to 1.5. It decreased. What happened to the pressure? We moved from 4.7 atm to what? 9.4. So, the volume decreased, the pressure increased. That's all that I wanted to teach you today. So, tomorrow we'll give you an assessment based on Boyle's law and the ideal gas law. And then you'll solve it on weekend and submit on Monday. So please watch the video, take the notes, and if you have questions, you are free to ask. And goodbye. Have a lovely night.